morning, friends. Just we discuss about the speed of a transverse wave in a string. We derive the equation wave speed v is equal to under root of t upon mu. Okay. Now the waves produced in a string are the transverse wave, while the sound waves are the longitudinal wave. Now, what is the speed of a sound wave in a medium? And also, when the sound waves are propagated through the solid bar or the solid material, at that time, what is the equation of the wave speed for the sound wave? Sound waves are the longitudinal wave. In longitudinal wave, when this type of the wave is propagated, the constituent particle of the medium oscillate forward and backward in the direction of propagation of a wave. That means, during the propagation of a longitudinal or the sound wave in a medium, the condensation and rarefaction is continuously formed, and as a result, the sound wave is propagated in a medium. So how we derive the equation of longitudinal wave or the sound wave during the propagation in a medium? For that purpose, the question is that obtain the equation of the speed of sound wave and also obtain the equation of the speed of a sound wave in solid bar or rod. For that purpose, the sound waves are longitudinal waves. Sound waves are longitudinal wave. In longitudinal wave, the constituent particles of the medium oscillate forward and backward direction along the direction of wave propagation. Propagation of wave. Right. The sound waves are the longitudinal waves, and in longitudinal wave, the constituent particle of the medium oscillate forward and backward direction along the direction of propagation of a wave. Now the property known as the bulk modulus B determines the volume of the element of the medium changes when the pressure on it changes. Right? And the dimensional formula of bulk modulus is m1 L minus 1 T minus 2. Again, the property like as the bulk modulus B determines the volume of element of the medium changes when the pressure on it on an element changes. Now listen. During the propagation of a longitudinal wave in a medium, the condensation and rarefaction is formed. So, when the condensation is formed in this region, the particles of the A medium are very close to each other. Therefore, in this region, the density is increased and also the pressure is increased. So, due to the increase in pressure, again the volume is expanded of this region. Therefore, the condensation is now transferred into the rarefaction. Right? Therefore, the property, that is the bulk modulus B, determine the volume of the element of the medium changes when the pressure on an element changes. The dimensional formula of bulk modulus is B is equal to M1 L minus 1 P minus 2. And also the longitudinal waves in the medium travel in form of compression and also the expansion or the rarefaction, or the changes in the density of the medium. And the dimensional formula of density is mass per unit volume. Therefore, M1 L minus 3. Right? The longitudinal wave travel in a medium the longitudinal wave travel in a medium in form of compression and expansion. That means the condensation and rarefaction. So, the density of the medium changes. The dimensional formula of density of a medium is rho is equal to M1 L minus 3 T 0. Thus, we saw that the speed of a longitudinal wave in a medium depends on two factors. One is the bulk modulus and second is the density. Thus, the speed of a sound or longitudinal wave in an A medium depends on a bulk modulus and density rho of the medium. Earlier in transverse wave, the speed of a transverse wave depends on the linear mass density and also the tension in a string. Here, the speed of a longitudinal wave in a medium depends on two physical quantity, bulk modulus and density of a medium. Right? Okay. To generate the V, that means the speed. to combine the bulk modulus and density in such a way that we obtain the dimensional formula M0 L1 T minus 1. Therefore, to generate we combine bulk modulus and density in such a way that we obtain dimensional formula of speed. Dimensional formula of a speed M0 L1 T minus 1. Our aim is to obtain the speed of a longitudinal wave. Therefore, here this speed depends on B and rho. Therefore, we have to combine these two physical quantities, bulk modulus and density, in such a way that we have to obtain the dimensional formula of a speed. The ratio or the dimensional formula of B upon rho is B upon rho is equal to dimensional formula of B. There is the M1 L minus 1 T minus 2 upon dimensional formula of density M1 L minus 3 T 0. Therefore, we obtain L2 T minus 2. Thus, equation of speed of longitudinal wave is V is equal to C upon under root of B upon. Here C is dimensionless constant. Dimensionless constant having unit value. Having unit value. Therefore, V is equal to under root of B upon rho. Clear? So, there is the speed of a longitudinal wave in a medium. Right? There is very easy equation to derive the speed of a longitudinal wave in a medium. Again, we repeat, the sound waves are the longitudinal wave. In longitudinal wave, the constituent particle of the medium oscillate forward and backward about their mean position along the direction of propagation of a wave. Right? Now the property bulk modulus B determines the volume of element of the medium changes when the pressure on element changes. So during the rarefaction and condensation, when the particles of the medium are combined in the region, so density is increased, as a result the pressure is increased. As the pressure increases, so again the volume is expanded. Therefore, the change in volume in element of the air medium take place due to the change in pressure. So how much volume is changes as the pressure change? So that can be determined by the physical quantity or the property bulk modulus. Therefore, the dimensional formula of the bulk modulus is M1 L minus 2 T minus L minus 1 T minus 2. Actually, the bulk modulus B is equal to change in pressure upon delta V upon V. That is the equation of bulk modulus. We learned about the bulk modulus in fluid. Now, the longitudinal wave travels in a medium in form of condensation and rarefaction. So, the density of the medium changes. The dimensional formula of density of the medium is m1 L minus 3 t0. Thus, the speed of a sound or the longitudinal wave in a medium depends on first the bulk modulus and second density of the medium. To generate the velocity v or the speed v, combine the bulk modulus and rho in such a way that we obtain the dimensional formula of the speed m0 L1 t minus 1. Now the dimensional formula of B upon rho ratio is B upon rho is equal to dimensional formula of bulk modulus m1 L minus 1 t minus 2 upon the dimensional formula of density m1 L minus 3 t0. Thus we obtain the L square upon t square. So that is the dimensional formula of square of a speed. Thus the equation of the speed of longitudinal wave must be square root of this ratio. Therefore the V is equal to C under root of B upon rho. Here the C is the dimensional less constant, having the value is unit. Therefore the speed of a longitudinal wave in a medium is V is equal to under root of B upon rho. Now our next case is that what is the speed of a longitudinal wave in solid or solid bar with a solid rod? Now in case of a solid, the bulk modulus is replaced by the Young modulus. The bulk modulus is replaced by the Young modulus. That means the medium of elasticity. The speed of a longitudinal wave in a solid depends on elasticity of a medium. So we place bulk modulus by Young's modulus, capital Y, in above equation. Therefore, the speed of a longitudinal wave in a solid is square root of Young modulus upon rho. Is the equation of a wave speed in a solid. Again, the speed of a longitudinal wave in a solid depends on elasticity of a medium, because compared to the fluid or the air medium, the solid cannot be compressed or the expand. That is depends on the elasticity of a medium, and elasticity of a medium is represented by the Young's modulus. Thus, the bulk modulus of above equation is replaced by the Young's modulus in case of a solid. Therefore, the equation of the wave speed of a longitudinal wave in a solid is V is equal to under root of Young modulus upon rho. So, there is the equation of the wave speed of a longitudinal wave or the sound wave in fluid or the air medium or the solid. Clear? Now, after the obtaining the equation of a speed of a longitudinal wave in a medium, now we are going to derive the Newton's equation or the Newton's formula for the speed of a sound wave in a medium. Now listen, just we have the equation. The speed of a sound wave in or longitudinal wave in air medium or the fluid is V is equal to under root of bulk modulus upon. Now Newton suggested that the propagation of a sound wave in air medium is the isothermal process. Isothermal process, that means the thermodynamic process during which temperature remain constant. Temperature remain constant. Here, as the longitudinal wave passing through the air medium, at that time condensation, rarefaction are formed. So the region in which the constituent particles are gathered, in this region the temperature is increased. And here the region in which the less number of the constituent particle, here the temperature is decreased, here the temperature is increased. But Newton suggested that during the propagation of a longitudinal wave, the process of longitudinal wave is a isothermal process. But the propagation of sound in air medium is the isothermal process. Right? Okay. That means the temperature does not change because the formation of the condensation and rarefaction are so fast. Right? Okay. Therefore, Newton suggested that propagation of sound wave is an isothermal process. Now, for isothermal process, we know that PV is equal to N kVT is equal to constant. That means the change in is equal to constant. The change in pressure into volume is always remain constant. Now we apply the change. Suppose the volume is constant, change in pressure is delta P. And here the pressure is constant, change in volume is delta V is equal to 0. Therefore, P delta V is equal to minus V into delta. Therefore, pressure P is equal to minus V delta P upon delta V is equal to, we can add delta P upon V is in numerator, taken in denominator of denominator, like this way, delta V upon V. We know that the right hand side of this equation is the bulk modulus, Therefore, substitute the bulk modulus is replaced by the pressure in equation 1. Thus, B is replaced by P in equation 1. Therefore, the speed of a longitudinal wave is V is equal to under root of P upon U. Equation 2 is the Newton's formula for speed of a longitudinal wave. Speed of a longitudinal wave. Again, the speed of a longitudinal wave or the sound wave in a medium for the fluid is V is equal to under root of ratio of bulk modulus to the density. Newton suggested that the propagation of sound wave is an isothermal process. Right? Isothermal process, that means the thermodynamic process during which the temperature remains constant. So here the Newton suggested that the propagation of a sound wave in a medium is take place at the constant temperature. Therefore, for ideal case, for isothermal process, the PV is equal to N, kVT is equal to constant. Therefore, delta PV is equal to constant. We apply the change in pressure and volume. First, the volume is constant, change in pressure, delta P. Plus pressure is constant, change in volume, delta V is equal to 0. Therefore, P delta V is equal to minus V delta P. Therefore, pressure P is equal to minus V delta P upon delta V. V is taken in denominator of denominator. Therefore, pressure P is equal to minus delta P upon delta V upon V. That is known as the bulk modulus. Therefore, bulk modulus is the pressure. Thus, the B is replaced by P in equation 1. Therefore, the speed of a longitudinal wave is V is equal to under root of P upon rho is the Newton's formula. As we substitute the value in this equation, the pressure is the 1 atmospheric pressure and density of the air medium is 1.29. We obtain the speed of a wave is 280 meter per second. So there is no that actual speed of a sound wave is 331 meter per second. Therefore, from Newton's formula, speed of a sound wave V is equal to under root of 1.01 into 10 is to 5 upon 1.1 into 10 is to 5 upon density is 1.29. Therefore, 280 meter per second is obtained. Is not matched with the practical value of the speed of a sound wave, but experimental value of speed of a sound wave in air medium is 331 meter per second. Thus, from this equation, the value of the speed of a sound wave is 15% less than the experimental value. It is 15% less than experimental value. There is okay. So there is the Newton's equation or the Newton's formula for the speed of a sound wave in a medium and also its value. Now, Next is write the equation of the Newton's formula and obtain the Laplace correction for the equation, Laplace equation. Right. For that purpose, the question is that write Newton's formula for speed of a sound wave and explain the Laplace correction. Now, Newton's formula is the speed of a sound wave is square root of p upon rho. That is the equation 1. Now, Laplace suggested that during the propagation of a wave, the change in volume is so fast that there is a little time to exchange the heat to maintain the constant temperature. Thus, the propagation of a longitudinal wave is not the isothermal process but adiabatic process. What is the adiabatic process? The thermodynamic process in which the exchange of the heat does not take place. That means the amount of the heat remains constant. Such process is known as the adiabatic process. So Laplace suggested that during propagation of a sound wave, propagation of longitudinal wave, the variation in volume is so fast that there is a little time. There is a little time to exchange the heat. So that is adiabatic process. Not isothermal. Not isothermal process. So Laplace suggested that the propagation of a longitudinal wave in a medium is not the isothermal process, but there is the adiabatic process. For adiabatic process, PV is to gamma is equal to constant. Therefore, the delta PV is to gamma is equal to 0. As we take the change, relative change in both physical quantity, first the pressure is constant, change in volume, therefore gamma into V is to gamma minus 1. Plus V is to gamma, constant, change in pressure is delta P is equal to 0. Actually, there is the relative derivative. First, the P is constant, derivative of V is to gamma. So we know that the derivation of x is to n x is to n minus 1. According to this formula, d by dx of x raised to n. So we know that n x raised to n minus 1. The same thing here we apply. The gamma is in multiplication, v has the power is decreased by 1, therefore gamma minus 1 plus gamma is to v is to gamma constant, change in pressure is delta. Therefore P gamma v is to gamma minus 1 is equal to minus v is to gamma delta. Therefore P is equal to, for the gamma P is equal to minus v is to gamma delta P upon v is to gamma minus 1. As the v is to gamma minus 1 taken in the numerator, so power becomes the negative. Right? Therefore, v is to gamma into v is to minus gamma plus 1 into p. So here the addition of the power gamma cancel, only v is obtained. Therefore, minus v into p is equal to gamma. Just wait. Here also the delta v. Here also delta is equal to this. Therefore, v is to gamma delta p is equal to delta v into v is to gamma minus 1 upon delta v. Therefore, gamma p is equal to minus p upon delta v upon d. So that is our bulk modulus. So Laplace suggested that by considering the propagation of a longitudinal wave as an adiabatic process, the value of bulk modulus is replaced by the gamma p. So here quite confusion. So here I can add like this way. Right? Therefore, gamma p is equal to minus p upon delta v upon v. That is our bulk modulus. Substitute in our equation 1. In equation 1. Therefore, speed of a sound wave v is equal to under root of gamma p upon rho. Gamma is equal to Cp upon C is equal to 1.4, 7 by 5. So by substituting the value in this equation, we obtain the speed of the sound wave is 30.3 meter per second. That is very close with the practical value. So it's the equation of equation 2 is Laplace equation. Again, write the Newton's formula for the speed of the sound wave and explain the Laplace correction. The Newton's formula is V is equal to under root of P upon rho. Now what is the Laplace correction? Laplace suggested that during propagation of longitudinal wave, the variation in volume is so fast that there is a little time to exchange the heat to maintain the temperature. To maintain constant temperature, so that there is an adiabatic process, not isothermal process. Right? For an adiabatic process, PV is to gamma is equal to constant. We take the change in PV is to gamma is equal to 0. Therefore, we take the relative derivative. P constant, derivative of V is to gamma is gamma V is to gamma minus 1 plus V is to gamma delta P is equal to 0. And as we simplify, we obtain the gamma P is equal to minus Vp upon delta V. Now, therefore, the gamma P is equal to minus P upon delta V upon V. That is our bulk modulus. Therefore, in equation 1, the bulk modulus is replaced by the gamma P, or the pressure is replaced by the gamma P. That is the equation of Laplace. Here the gamma is the ratio of the Cp upon Cv. That means the two specific heat at constant pressure and constant volume. So its value is 7 by 5. That means the 1.4. As we substitute the value now in this equation, gamma is 1.4, pressure is 1.1 into 10 is to 5, and density is 1.29. We obtain the speed of a sound wave in a medium is 331.3 meter per second. That's the very close to the experimental value, 331 meter per second. Just meet here. Exchange the heat to maintain constant temperature. Thus, it is adiabatic process, not isothermal. Clear this? So both are the most important for the 2 marks question, Newton's formula and also the Laplace formula. Very easy, but here 1 or 2 times you have to add down the mathematical step, because that is the derivation.